the system that built 4 multi-billion-dollar world-altering ventures in parallel.
We're decoding the operating system of Elon Musk.
Exactly. And to do that, we have to start with the scene that it perfectly encapsulates the man's contradictions.
Right. So picture this. You're in a high-end, very exclusive Silicon Valley seafood restaurant. Musk arrives late, which, is pretty standard for him, and he looks completely exhausted.
Utterly wiped out. And he proceeds to order this huge plate of fried lobster. But it's not just fried lobster, it's soaked in black squid ink.
Which is already a choice. And then for dessert.
A towering neon yellow cotton candy sculpture. I mean, you can't make this stuff up. And he just devours it, completely blowing his notoriously strict self-imposed diet.
So you have this moment of just like physical absurdity. But at the same time, the conversation is incredibly serious.
Deeply serious. As he's eating this insane meal, he's sharing his deepest existential fear with the journalist sitting across from him. He's worried that his close friend, the Google co-founder Larry Page, might accidentally build an artificial intelligence that's capable of destroying humanity.
So you have this high-stakes philosophical conversation against this backdrop of pure sugary chaos. It's a lot.
And then, right as the dinner ends, he leans forward, looks the journalist dead in the eye, and he asks the central, provocative question we're here to answer today.
Do you think I'm insane?
And that's our mission for this deep dive. We are going into the primary accounts of his life, his strategic thinking, how his businesses even started, and the almost unbelievable financial and engineering challenges he faced launching SpaceX, Tesla, and Solar City, all at the same time.
Yeah, we have to get past this simple label of insanity.
Yeah.
We need to explore the root of this relentless drive. Is it madness, or is it just an exceptional level of conviction executed with an absolute, unyielding intensity?
To do that, we have to try and extract what you might call his unified field theory, the thing that connects electric cars and residential solar and orbital rockets.
Because it's not a coincidence that he built all three. The sources make it really clear that it's an integrated, singular survival strategy.
He's building an architectural framework. That's the way to think about it. A framework to ensure the long-term viability of human consciousness, both on this planet and off of it.
And to really understand that, you have to go back, right back to the beginning, to the crucible that forged this very specific, very unique character.
Mm-hmm.
Okay, let's unpack this first major section. The crucible of character.
Yeah.
We have to start in South Africa, a place of just intense contrasts that directly molded his tolerance for risk and for stress.
You see that immediately when you look at the contrast between his two family lines. So on his maternal side, you have the Haldemans, and they had this incredible, almost mythical lineage. They were known as the Flying Haldeman.
The Flying Haldemans.
Yeah.
It sounds like something out of a storybook.
It really does. His maternal grandparents, a man named Haldeman and his wife Wynne, they just embodied this extreme, almost audacious level of risk-taking and adventure.
But it's more than just being adventurous, isn't it? I mean, they weren't just tourists going on a safari.
Not at all. They moved from Canada to South Africa, and they did it by flying their own small plane across North America and then across Africa. I mean, think about the logistical feat of that at the time. It's staggering.
And once they got there, they kept going. They went on these month-long expeditions, famously searching for the legendary lost city of the Kalahari Desert.
It just suggests a family DNA that views immense life-threatening risk as, the guideline for a life well lived.
But there's a flip side to that, right? The sources point out this.
Yeah.
This necessary counterbalance to all that adventure.
Absolutely. The grandfather, Haldeman, also held these incredibly strong, almost puritanical, moralistic views. He was very anti-government. And in his house, he forbade things like swearing, smoking, Coca-Cola, even refined flour.
So on one hand, you have this immense external adventure, and on the other, this intense internal discipline and self-control. It's a really interesting paradox.
It is. Now, you contrast that audacious, disciplined spirit with his immediate home life. He grew up in Pretoria, South Africa, which was steeped in the tension and, frankly, the violence of the apartheid regime.
And after his parents divorced, Elon makes this choice that, from the outside looking in, seems totally baffling. He chose to live with his father, Errol.
Yeah, and he was just a child making a decision based on what seemed like fairness to him at the time. He explained it later. He said he felt a kind of pity. My father seemed sort of sad and lonely, he said, and my mom had 3 kids, and he didn't have any. It seemed unfair.
Wow. So he chose to be the moral ballast for his parent. I mean, that's a heavy, heavy burden for any kid to take on.
And that decision came at a tremendous psychological cost. The source material is It's brutally frank about this. His siblings described their time living with Errol as a form of psychological torture.
Elon himself called his childhood misery, and he said his father was, quote, good at making life miserable. He even mentioned that Errol had serious chemical stuff, which implied some pretty significant emotional or psychological instability.
And this controlled, emotionally fraught, and often painful upbringing is, you could argue, it's the single biggest determinant of his later business career.
How so?
Well, it instilled in him this immense, almost pathological tolerance for working through profoundly difficult, stressful, even excruciating situations. I mean, if your baseline of what's normal is psychological misery.
And then the stress of 3 rocket failures in a row doesn't seem quite so catastrophic.
It's just another Tuesday, right? That ability to absorb and function under what would be crippling stress for anyone else is a complete hallmark of his management style later on.
Okay, so from that emotional drama, we see the engineering mind emerge as a kind of escape route. And the defining moment, the formative moment, came when he was 10 years old in a Johannesburg mall.
He saw a computer, a Commodore VC-20, and for him it was like the world just crystallized. It was a genuine, whoa, holy cow, epiphany.
The computer came with a workbook
Right.
to teach you the programming language, BASIC.
It did, a 6-month workbook. But Musk, exhibiting what he later called his super OCD intensity, basically locked himself away for 3 days straight, teaching himself the entire programming language and finishing the whole 6-month course.
In 3 days.
3 days. And this wasn't something that was encouraged at home. The sources note his father, who was an engineer himself, was really dismissive. He called the machine just for games.
But for Musk, it unlocked this unique aspect of his intellect. He calls it his visual processor.
Exactly. He described his mind as working almost literally like a computer graphics chip. It's constantly rendering these images with engineering clarity. He doesn't just see abstract ideas, he can visualize the interrelationships and algorithmic relationships vividly.
So he's not thinking about acceleration and momentum as equations on a page.
No, he's seeing them. He's seeing them as physical forces and vectors playing out in real time in his mind. And that is the core skill that allows him to design something as complex as a rocket engine or a massive battery pack.
And that innate audacity, that willingness to flirt with disaster, wasn't just confined to programming, was it? We see it in his teenage years.
Oh, yeah. He and his cousins, they experimented with homemade explosives and rockets. We're talking about mixtures of saltpeter, sulfur, charcoal, and then they'd mix granulated chlorine with brake fluid.
Which sounds incredibly dangerous.
He looks back on it now and jokes that he's lucky he still has all his fingers. But the point isn't just the explosives, it's the immediate hands-on, high-risk application of physics. It's learning by doing and doing at the edge of what's safe.
And they took that same high-risk attitude directly into business. They had this audacious plan to start a video arcade.
A remarkable feat for teenagers. They picked a location, they managed to secure a lease agreement, and they started navigating the whole complex permit process, all without any parental help.
The only thing that stopped them was needing an adult signature, right?
Yeah, they needed an adult to finalize the commercial lease and the permits. And neither their father nor their cousin's father would sign off. But the pattern was already there. High risk, high reward, hands-on execution.
That quest for high-risk opportunity is what pushed him to leave South Africa when he was 17.
There were 2 critical reasons, and they were interwoven. First, he urgently wanted to get to the United States. He saw it as the land of opportunity, and he used his Canadian ancestry as a stepping stone to get there.
And the second reason?
He was actively avoiding military service in the apartheid regime. He simply refused to support it on moral grounds.
So he ends up at Queen's University in Canada and then transfers to the University of Pennsylvania. And he pursues dual degrees.
This pairing is just foundational to who he is. He gets a degree in economics from Wharton and a degree in physics. So you have the hard science of engineering married to a deep understanding of finance, markets, and capital.
And this is where we get the legendary college side hustle, the story that everyone knows.
The infamous speakeasy.
Yeah.
He and his roommate found this enormous 10-bedroom fraternity house off campus that nobody wanted. They rented it themselves and turned it into an unlicensed speakeasy.
$5 for all you can drink.
And Musk, who wasn't a heavy drinker himself, was the operational manager. He was the brains behind the whole organization.
And you have to think about the skills he's learning there. He's running a cash business. He's managing logistics, risk, security. He could make an entire month's worth of rent in just one profitable night.
This wasn't just a party. It was an early lesson in maximizing revenue, minimizing overhead, and just pragmatic operational management. These are all skills that are totally transferable to running a complicated manufacturing business later on.
It was also during college that he really formalized his grand strategic vision, what he would later call his master plan.
He confided in friends and his girlfriends at the time, long before he had any money or success, that he saw three areas that were just ripe for fundamental disruptive change.
The internet, renewable energy, and space.
And he wasn't just, idly dreaming about it. He vowed that he would pursue projects in all three of those areas. He insisted this was his core mission, his destiny, years before the first dot-com bubble even really hit.
That intent is just so crucial for understanding his motivation later. He wasn't some trend-sniffing entrepreneur looking for the next easy billion.
No, he was executing a self-assigned, civilizationally critical, long-term mission. And that conviction, born in his challenging childhood and formalized in college, carried him directly into his first startups.
Which brings us to Zip2 in 1995, founded with his brother, Kimball. The idea was incredibly simple, but for the pre-Google era, it was revolutionary.
It was a searchable directory of businesses that was tied directly to Maps. It was basically the direct precursor to Google Maps and Yelp combined.
And that initial phase was just an absolute grind.
Relentless.
Yeah.
And brutal. Musk and Kimball literally lived in their tiny 20 by 30-foot Palo Alto office for the first 3 months. They were showering at the local YMCA. Musk slept on a beanbag right next to his desk.
And their diet was not great.
Not at all. They survived by eating up to 4 meals a day at the cheapest, most accessible place that was open 24 hours, Jack in the Box.
The sources paint a really vivid picture of what the sales team was up against. They were facing constant, soul-crushing rejection.
They're going to newspapers, to local businesses, trying to sell them on internet advertising, and they were told over and over again that it was the dumbest thing they had ever heard of.
It's a period that often gets forgotten, but it underscores that sometimes groundbreaking innovation is really just about outlasting the skeptics.
Fortunately for them, they did outlast them. Zip2 sold to Compaq in 1999 for $307 million. Musk's personal take was a very respectable $22 million.
Now, here is where his throwback mentality kicks in and just separates him from all of his dot-com peers.
Right. Most of his peers would have retired. They'd have bought a mansion, a boat, become a venture capitalist, start risking other people's money. Musk did something that was, by those standards, completely insane.
He immediately plowed the majority of his personal fortune, about $12 million, into his next venture, X.com, an online bank.
It was an insane, almost industrial age level of risk. He put his entire personal safety net, his inheritance from Zip2, directly back onto the high-stakes table. He was behaving more like a 19th century industrialist, betting his entire family fortune than a modern dot-com millionaire cashing out.
X.com then quickly merged with a company called Confinity.
Yeah.
And Confinity happened to have this viral, rapidly growing product called PayPal.
And Musk's tenure as CEO of the merged company was it was marked by conflict from day one, both internal and external.
He forced a total brand shift, right?
Yeah.
He insisted the company use the name X.com, which turned out to be a marketing disaster.
It was. But more importantly, he instigated a huge technological conflict internally. The original Confinity engineers, they all preferred Linux, which was seen as the standard open-source platform for new internet companies.
But Musk insisted on shifting the entire platform to Microsoft's C++ on.
He did. And the technical reasoning here, which often gets glossed over, is really critical to understanding his engineering focus. Musk knew that the Microsoft C++ development tools, which had been refined and matured by the gaming industry, offered far superior sophistication, performance, and crucial memory management capabilities.
Capabilities that were essential for the kind of real-time, high-volume, fraud-free financial calculations he was envisioning.
Exactly. He wanted the Ferrari of payment systems, and he saw the gaming industry's libraries as the path to get that sophisticated performance, even if it meant totally alienating his core engineering team.
And this internal technical conflict, combined with the branding disaster and all the issues they were having with customer fraud, led directly to his removal as CEO in the year 2000.
While he was on his honeymoon, no less, it was a humiliating, incredibly painful lesson in corporate control and the absolute necessity of retaining it.
And his view of PayPal today really reflects that grand vision that was left unfulfilled.
Oh, absolutely. He lamented that PayPal hadn't developed any truly meaningful features since 2001. He believed the ultimate objective, the realization of this unified financial vision, was to achieve instant, fraud-free, and most critically, fee-free internal transactions.
He felt that capacity to deliver fundamental value to the economy was the great goal that the company just missed.
So he exits the dot-com world in 2002 with another huge payday, but also with the trauma of being ejected from his own company while trying to fulfill this massive technological vision. That financial win, paired with the psychological trauma and a severe bout of malaria, led directly to the formation of the triple threat we know today.
Okay, so after that PayPal exit, Musk was physically a wreck. He was weakened, he'd lost a tremendous amount of weight while fighting off malaria, and this physical reckoning seems to have focused his mind entirely.
It did. He was focused on doing something lasting, something truly meaningful. And the two options he kept coming back to were solar energy or space colonization.
But his first foray into space wasn't the industrial giant SpaceX. It was actually a philanthropic effort, wasn't it?
It was. It was called the Life to Mars Foundation, and the goal was purely to restore public enthusiasm for space exploration, which, had faded pretty dramatically since the Apollo era.
And the initial plan was
Memorable.
the Mice to Mars mission, yes. He planned to send mice to Mars and back for about $15 million. And rather memorably, the plan was for them to procreate during the months-long trip.
You can just imagine the reception that got. Oh, yeah. His friends joked that the fornicating mice would require a hell of a lot of cheese. But the core idea was pure spectacle. It was a technically feasible, grand, attention-grabbing mission costing only about $20 million total that would force the public and politicians to start thinking about Mars again.
That philanthropic effort is what led him directly to the infamous Russian rocket negotiations in 2001.
Right, Musk, along with a couple colleagues, Jim Cantrell and Mike Ressy, went to Moscow. They were trying to buy 3 refurbished intercontinental ballistic missiles ICBMs to use for the mission. He had $20 million in his pocket, and he thought this was more than enough.
And you have to picture the scene. They met the Russians in this ornate but clearly neglected pre-revolutionary building. The atmosphere was just thick. They did the traditional vodka shots to space, and then the business started.
Musk asks the price for 3 missiles. And the Russians, who likely sensed this naive American with way too much money, quoted him $8 million per missile.
Musk was outraged. He felt like they were trying to fleece him. So he counters, offering $8 million for 2 missiles. It was a massive psychological gamble.
And it backfired. The Russians just scoffed. They immediately ended the negotiation and basically intimated that he clearly didn't have the money or the seriousness for this conversation.
So Musk, refusing to be disrespected or extorted, just storms out of the meeting, right onto the street.
And that failure, that raw moment of being dismissed by the established gatekeepers of space, it changed everything. Musk's reaction wasn't despair. It was this defiant, strategic pivot. He decided, I guess we'll have to build it ourselves.
And within months, Space Exploration Technologies, or SpaceX, was founded in 2002.
And the mission was instantly existential. It was far beyond just launching commercial satellites. The core mission was, and it still is, turning humans into space colonizers and a multiplanetary species. This, in his mind, is the ultimate insurance policy against a worst-case scenario happening and extinguishing human consciousness.
And that Mars agenda is still the rallying cry for every single employee.
It is. They started in these incredibly humble industrial surroundings, a 75,000 square foot warehouse in Hawthorne, California. Early setup was just folding tables, Dell laptops, and printers. But the vision was radical.
They aimed to be the Southwest Airlines of space.
Which meant tearing up the entire existing cost structure of rocketry. They would build better, cheaper engines like the highly successful Merlin, and they'd fine-tune the assembly process for extreme speed and repetition. The goal was launching multiple times a month, not relying on the traditional, slow, lucrative government contract model.
And Musk had this incredible eye for identifying talent that shared his ethos of radical efficiency.
He did. He recruited people like Tom Mueller, who was already famous in the amateur rocketry community, for building the world's largest liquid fuel rocket engine by an amateur, a whopping 13,000 pounds of thrust.
Mueller was working at the aerospace giant TRW at the time, where their latest engine cost $12 million.
Right. And Musk didn't ask what the TRW engine cost. He asked what Mueller could really build it for if he had no constraints. And that one question, fundamentally challenged the entire cost equation of the industry.
This whole ambitious bootstrapping plan was only possible because of the PayPal money, though.
Absolutely. The eBay acquisition of PayPal in 2002 gave Musk over $100 million in personal liquidity. And crucially, this cash guaranteed a couple of years of security, and even more importantly, it ensured he maintained absolute control. It prevented him from being ejected like he was at X.com.
But the Falcon 1 launches. That's where the aggressive naivete crashed headlong into physics and reality.
It really did. Musk set this initial, highly optimistic timeline of 15 months for the first launch. It ended up taking nearly 4 years.
And the first 3 launches failed spectacularly.
These failures consumed his personal fortune at a terrifying rate. The third failure in particular was just crushing. And initially, it was publicly blamed on an unnamed technician who supposedly failed to tighten a fitting on a fuel pipe.
Which led to this immense internal drama.
Oh, yeah. The technician, a guy named Holman, flew back to the headquarters and had a screaming match with Musk, maintaining his innocence. It was only after this painstaking debris analysis that they found the real culprit.
Which was?
Environmental corrosion of an aluminum B-net. It was caused by the salty air at Kwajalein Atoll, where they were launching from.
So it wasn't human error, it was a materials science failure.
Exactly. Caused by the unique corrosive environment. It was a painful, expensive lesson. It forced them to slow down and fundamentally rethink their entire approach to material sourcing, testing, and production methods in ways that traditional aerospace contractors already knew, but they learned to do it at a fraction of the cost.
So the company was down to possibly only one more attempt, the famous make-or-break moment.
And in September 2008, the fourth launch finally achieved orbit. It was met with just absolute rapturous cheers back at headquarters. They had survived, but just barely. And it forced Musk to risk every last dollar he owned.
Meanwhile, the second leg of this unified field theory was emerging, Tesla Motors.
And this is built not on rocketry, but on a critical revelation by one of the co-founders, J.B. Straubel.
We should pause here for a moment of delightful detail. Straubel had a 2-inch scar on his cheek from an exploding beaker during a high school chemistry class.
A perfect metaphor for the inherent risks of radical tinkering. It's fantastic.
So what was his revelation?
Straubel realized that thousands of these small, cheap, 18650 lithium-ion cells, the kind used in laptops, could be strung together to form a highly energy-dense car battery pack. Theoretically, this could give a car an unheard of 1,000-mile range. This was the paradigm shift.
And they launched the Roadster in 2006. Its purpose was very intentional. It wasn't designed to be cheap or utilitarian.
No, it was a gorgeous, high-performance 2-seater convertible, 0 to 60 in about 4 seconds, with a usable 250-mile range. Its sole purpose was to prove to the world that all electric cars have sucked until then, and that EVs could be fun, high-performance objects of desire.
But the supply chain logistics were an absolute nightmare.
The early production plan was ridiculously complex. It involved panels from France, motors from Taiwan, battery assembly in Thailand, final assembly in England, and then shipping them around Cape Horn.
It's just an insane, convoluted global supply chain. And it caused immense cost overruns and delays.
The development cost just ballooned. It went from an estimated $25 million to a staggering $140 million. When a new executive asked how the car would actually be physically manufactured, the operations head famously replied with zero hyperbole that a miracle is going to happen.
That miracle needed money. And heading into late 2008, both Tesla and SpaceX were running out of cash at the same time, right in the middle of the worst global financial crisis since the Great Depression.
It was the worst possible timing. Musk had to convince these shell-shocked investors to fund an electric car company that, in his own words, sounds like it is shit and doomed.
And then there was the third leg, Solar City.
This venture was founded by his cousins, the Rive brothers, with Musk acting as chairman and largest shareholder. He was deliberately linking his fortunes to the business.
Their strategy was pure efficiency and customer focus. Make solar painless.
Right. They chose not to manufacture the panels themselves, which avoided massive initial capital costs. Instead, they bought them and handled the entire process installation, financing, and leasing. They eliminated the crippling high upfront costs for consumers.
And Musk saw this not just as a business opportunity, but as a core necessity for humanity's survival.
He cited figures that enough solar energy hits the Earth in just 1 hour to equal a year's worth of worldwide energy consumption. The energy is already there. The challenge is just infrastructure and capture.
And this is where the intentional synergy becomes explicit. This is where you see the unified field theory in action. Solar City began selling energy storage systems.
Those battery packs manufactured at the Tesla factory to augment the solar arrays.
Right. The battery storage smoothed out solar's intermittent output, helping customers manage their energy and potentially even leave the electrical grid entirely.
So the three companies weren't separate startups at all. They were components of a single integrated system designed to transition humanity to sustainable energy and secure an off-world backup. The car creates demand for the battery, the solar array charges the battery, the rocket protects the species. It all fits together.
We've established the intense childhood crucible and the incredible financial and engineering risks he took to launch these three ventures at the same time. Now we have to look at the engine driving it all, the sheer intensity and sacrifice of the Muskian method.
You have to start with the sheer scale of the workload and the personal sacrifice. I mean, Musk operates on a completely different plane. Our sources detail his life as that of a nonstop traveler.
He took 165 flights in 2013 alone. The average American takes, what, 4 flights a year?
Right, and he works 7 days a week, constantly splitting his time between Los Angeles for SpaceX and the Bay Area for Tesla. He's essentially managing two capital-intensive, world-changing companies simultaneously.
The sources also paint a pretty painful picture of his personal life as an almost calculated afterthought.
Yeah, when he was attempting to carve out time for dating, he famously calculated that he needed to allocate maybe 10 hours a week as a minimum. It sounds like an efficiency calculation applied to human connection.
And it illustrates that his macro-empathy for the species often comes at the cost of micro-empathy for the individuals right in front of him.
But the ultimate sacrifice was financial, especially in that terrifying year of 2008. When both companies were on the brink of collapse, he told a close friend with absolute seriousness, "I will spend my last dollar on these companies. If we have to move into Justine's parents' basement, we'll do it."
And he wasn't just risking venture capital funds. He risked his entire personal fortune, the $22 million he'd netted from Zip2. He was demonstrating an all-or-nothing commitment that just did.
Ah!
It differentiates him entirely from the typical Silicon Valley entrepreneur. That is the definition of high conviction.
And the physical toll is constantly evident. He often looks utterly exhausted, with these deep, shadowed valleys under his eyes from chronic sleep deprivation. He genuinely believes that life is short and should be embraced by working as hard as humanly possible.
He often seems to just ignore the consequences to his own body, which brings us back briefly to that absurd image of the fried lobster and yellow cotton candy from the intro.
Exactly. That feast was likely a desperate, momentary burst of hedonism in a life that was otherwise totally governed by self-imposed ascetic rigor and work.
That intensity is the wellspring of his management style, which is often described as a synthesis of a general and an architect. He has zero tolerance for bureaucracy, and even less for standard practices.
If an employee tells him something is impossible or that they made a choice because it was the standard way things had always been done, he views that as a catastrophic failure of critical thinking. He will often terminate the conversation or even the employment relationship right there on the spot.
He seeks out people who can maintain his pace. He praises engineers like Steve Davis, who worked 16 hours a day every day for years. Musk noted he gets more done than 11 people working together.
He's looking for a workforce that operates at his level of dedication, which is, inherently unsustainable for most human beings.
And he's notorious for setting aggressive deadlines which he himself admits are often downright liar deadlines.
The sources clarify that these deadlines are calculated assuming everything goes right, and that everyone involved possesses Muskian abilities and work ethics. When he was later reminded of that incredibly unrealistic 15-month target for the first Falcon 1 launch, he reportedly acted shocked, saying, "This isn't like software," which is a painful recognition of the difference between code and complex physical hardware.
That sounds incredibly effective for driving speed. But we have to ask, is there any discussion in the sources about the emotional toll or the massive turnover rate caused by managing from a place of perpetual impossible threat? I mean, if the deadlines are knowingly false, doesn't that inherently break trust with your engineering teams?
It creates a tremendous cost in terms of human capital, absolutely. But the sources reveal this psychological trick he employs to try and circumvent that trust deficit. He doesn't just set the deadline and command compliance.
He challenges the employee directly.
Exactly. He'll say something like, "I need the impossible done by Friday at 2 p.m. Can you do it?"
And when you say yes, the entire dynamic shifts.
Precisely. You are no longer working hard because he told you to. You're working hard for yourself. You now own the impossible task. The goal is to maximize that sense of personal responsibility and agency, even if the task is objectively impossible.
And if you fail, or if you tell him definitively that something is impossible,
The threat is real and absolute. He'll say, Fine, you're off the project, and I am now the CEO of the project. I will do your job and be CEO of two companies at the same time. I will deliver it. And the sources confirm that he has repeatedly delivered on projects after taking them over, which reinforces that absolute belief in his own singular capacity to solve problems.
This relentless pace and singular capacity leads directly to his engineering philosophy: vertical integration and speed above all else.
He preferred to build as much as possible in-house, compensating for a lack of a traditional R&D budget by hiring smart people who could outwork and outthink third-party suppliers and vendors.
This in-house manufacturing control is the defining architectural feature of both SpaceX and Tesla. He famously implemented a signature factory aesthetic at both the Hawthorne and Fremont plants.
Pristine white epoxy floors and white walls. But this isn't about cleanliness, it's about integration. He places the engineers' desks directly on the factory floor near the welders and the machinists.
And at SpaceX, there's a 3-story glass office structure that sits literally in the center of the factory. This design forces the engineers to walk through the production area and watch the machines, the materials, and the production process at all times.
The mechanism here is clear. It fosters immediate collaboration, it eliminates bureaucratic distance between design and reality, and it makes the factory the central nervous system of the entire company. It's an old Henry Ford model applied to advanced 21st century technology.
And this control enables just extraordinary rapid iteration and testing.
At SpaceX, they built a third-floor test bed that replicates the rocket's internal hardware and electronics. It allows engineers to run thousands of flight simulations in real time, making changes on the fly.
And the efficiency gained is just staggering. The source recounts a critical incident right before launch where engineers spotted a software error. Because of this vertically integrated test bed, they were able to change the file, check the hardware response, and send the update to the rocket on the launch pad in under 30 minutes.
Now, you compare that to the traditional siloed aerospace systems, like NASA's legacy process, where that same change and vetting process could easily take weeks. This ability to iterate at speed is why he's been able to outpace established giants who are constrained by all this bureaucratic and contractual distance.
He would seek out suppliers from totally different fields, like agricultural tank makers for rocket fuel tanks, just to try and save costs. But when suppliers couldn't keep up with his pace or his demands for absolute quality, he was ruthless.
The famous anecdote highlights his impatience. He once told a slow supplier, "You're fucking us up the ass, and it doesn't feel good." This kind of direct confrontation ultimately drove him to increase his internal welding capacity and ditch those slow contractors entirely, prioritizing control and speed over outsourcing.
Finally, let's touch on this public versus private tension, which is really central to his financial strategy. He strongly resists taking SpaceX public.
And he cites his experiences with Tesla and SolarCity as the reason. He argues that public markets impose extreme stock volatility, and they distract employees from their primary mission of creating great products by forcing them to focus on the manic depressive nature of the stock.
Tesla and SolarCity went public out of necessity, right? They needed huge amounts of equity capital and debt to fund things like the massive solar leases and the Gigafactory construction.
Exactly. But he wants SpaceX to have the best aspects of a public and private company, meaning steady, predictable growth without that quarterly pressure. To maintain that stability and fund the Mars mission, SpaceX has to be ruthlessly profitable.
Based on their annual expenses, which sit around $800 to $900 million, they need to achieve about 12 flights per year, 4 of which have to be the higher margin Dragon or Falcon Heavy flights, just to hit 10% profitability.
And that's a relentless financial challenge, driving a relentless production schedule, ensuring that the mission Mars is always served first.
We've thoroughly covered the methodology of execution. Now, let's zoom out to the sheer scale of ambition, because the vision for the future is always expanding beyond the current set of companies.
Right. And the integrated vision really culminates in the Gigafactory. This was his radical solution to Tesla's massive projected battery demand. It wasn't just a factory. It was envisioned as the world's largest lithium-ion manufacturing facility.
The integrated goals are crystal clear. By achieving that kind of scale, they would significantly lower battery costs, they'd improve energy density, pave the way for the Model 3 with its $35,000 price target, and facilitate the goal of 500-plus mile-range EVs.
Making the whole electric transition financially and logistically compelling for the mass market.
And again, the Muskian obsession with speed drove the construction.
He even calculated the cost of delay, estimating that a 6-month delay meant losing over $1 billion a month in potential revenue, assuming the Fremont car factory was ready and just waiting for batteries. He was willing to build a second gigafactory to compete with the Nevada site just to ensure maximum velocity.
Beyond his core companies, his mind constantly drifts toward disruptive infrastructure. In 2013, he proposed the Hyperloop concept, a totally revolutionary form of high-speed transport.
And its genesis was fascinatingly negative. It was born out of his intense hatred for California's proposed high-speed rail project, which he famously called the slowest bullet train in the world at the highest cost per mile.
Initially, he framed the Hyperloop purely as a thought experiment, right? It was a way to demonstrate to the public and legislators that better, more efficient ideas existed, hoping to pressure the state to cancel the rail project.
But the public reaction was so intense, people truly believed he could pull it off. And that forced his hand. He had reached a level of public confidence where he felt he couldn't let his adoring public down, so he committed to building at least a prototype to keep the vision alive.
And we see his mind pushing beyond terrestrial infrastructure entirely with his proposal to surround Earth with thousands of small communication satellites, creating a space-based internet.
This is, again, pure synergy. It would provide high-speed internet to remote, unserved areas globally, and at the same time, it would serve as a highly efficient backhaul network. And it leverages SpaceX launch capacity. It's just another piece of integrated architecture designed to connect and improve human capability.
This incredible ambition stands in really sharp contrast to a prevailing sense of technological stagnation that was common in Silicon Valley right around the time he launched Tesla and SpaceX.
Absolutely. Peter Thiel, the PayPal co-founder and a major investor, he lamented this stagnation. He famously said, "We wanted flying cars, instead we got 140 characters," suggesting that fundamental innovation had stalled between Google in 2002 and the iPhone in 2007 and was just focusing on apps and ads rather than heavy, hard-tech breakthroughs.
And the skepticism was academic as well. A physicist named Jonathan Huebner argued in 2005 that the major game-changing ideas, the trunk of the innovation tree, had already been mined.
He suggested that innovation is a finite resource and that we are now only refining past inventions, concluding that the pace of breakthrough invention was slowing down.
Skeptics leverage this idea. The economist Tyler Cowen called Musk an attention seeker, suggesting his work merely pushes problems back. Electric cars still require power generation, for instance. And he doubted he ever intended to build the Hyperloop.
There was also the significant critique from Vaclav Smil, a renowned author on manufacturing, he missed the point entirely. He lumped Musk in with space tourism, failing to recognize that SpaceX competes fiercely at the industrial end of space. It builds products in the U.S. with American workers, and ironically, it perfectly exemplifies the kind of advanced mechatronic machines that Smil himself often celebrates.
The counterargument and the core of Musk's defense is that his approach is the synthesis needed to break that stagnation. He fuses software, electronics, and advanced materials, the mechatronics, with Henry Ford's model of extreme vertical integration.
Google co-founder Larry Page is famously envious of this approach. He called Musk an inspiring example for dedicating his time and his massive fortune to solving grand, fundamental problems. Sustainable cars, mitigating global warming, achieving multiplanetary life, rather than focusing on increasingly trivial, inconsequential goals.
Which brings us to the ultimate overriding goal, Mars.
Turning humans into space colonizers is the stated life's purpose that binds all of these ventures together. At SpaceX headquarters, the images show a barren Mars today, right next to a conceptual rendering of a terraformed Mars with green landmass and vast oceans.
And the architecture supporting this vision is deeply considered. It illustrates that blend of physics and engineering perfectly. The entire system requires a methane engine for the Mars vehicle.
And not because it's a better fuel for Earth, but because of how it integrates with the off-world goal. Methane is liquid at a temperature that's similar to liquid oxygen, which allows for common bulkheads in the massive fuel tanks. That saves weight and complexity.
And crucially, methane is the lowest cost fossil fuel, and it can be generated directly on Mars using its CO2 atmosphere and available water ice, a process called sabatier.
Right. Using CO2 and water ice, you create both methane, CH4 for fuel, and oxygen, O2 for combustion. It's a closed-loop system designed for self-sufficiency and long-term non-reliance on Earth.
However, the timeline remains vast.
Musk estimates that terraforming Mars would take somewhere between a century and a millennium. He admits there's a tiny chance of it happening in his lifetime, but his personal commitment remains absolute.
His life is framed entirely by this singular ultimate objective. He stated, "I would like to die on Mars, just not on impact."
Ideally, he would visit, return, and then go there to stay around age 70. His willingness to risk everything, the relentless pace, the management style, it all flows directly from this existential imperative. So let's synthesize the answer to the question Musk posed over that bizarre dinner. Do you think I'm insane? What the sources reveal is not traditional insanity, but a rare and profound intensity of conviction.
A conviction forged in the crucible of his childhood and coupled with an exceptional visual ability to integrate physics, engineering, and finance to execute these decade-long multi-industry visions.
It's a high-risk nature that's rooted in early trauma and then reinforced by financial success. And it's executed with an almost superhuman focus that constantly pushes the limits of human endurance.
The paradox here is just so striking. The ruthless, demanding CEO, who often seems aloof or harsh toward individuals, is contrasted with this massive, almost transcendent macro empathy he holds for the human species as a whole.
His deepest fear is humanity's self-imposed or accidental annihilation. His fear of AI is one example, his concern over climate change another. And he genuinely views his companies as providing a necessary protective framework against that annihilation.
And this intense love for the species sometimes obscures the strong emotions and needs of the individuals around him, which results in that aloof and demanding persona.
But the true importance of his legacy, particularly for the U.S. economy, may lie in something more immediate and terrestrial. He is almost single-handedly responsible for bringing back ambitious, integrated manufacturing to the U.S.
Building colossal factories, employing thousands of American workers to forge metal and build highly complex physical machinery at a time when technological innovation was dismissed as merely apps and advertisements.
He proved that physical, hard-tech, vertically integrated goals are still achievable and scalable.
We've seen how Musk views every major project, Tesla, SpaceX, Solar City, as a critical piece of a singular protective framework for humanity. And if the future depends on achieving these seemingly impossible technological breakthroughs, it requires that all-or-nothing relentless approach we've analyzed today.
So here is our final provocative thought for you to chew on, building on the knowledge we've distilled.
If you accept that his willingness to risk everything, combined with vertical integration and an intentionally relentless pace, is what ultimately solve massive, impossible problems in space and energy. What existing, seemingly impossible problem in your field could be solved by applying a similar all-or-nothing vertically integrated approach? Think beyond the incremental and decide what impossible task you are willing to own completely.